And 3 says to prove this identity, prove that the tan of A plus B is equal to tan A plus tan B over 1 minus tan A tan B. So to do this proof, we have the tan of A plus B. We know that the tan of A plus B is equal to sine over cos. So it's going to be equal to the sine of A plus B divided by the cos of A plus B. That's what we're going to have. But then what do we know? What do we know? We now know that sine A plus B, we know a formula for this. This is given by, the formula is given by sine A plus B is sine, write it here. This formula for sine A plus B is given by, give me some space. It's given by sine A cos B plus cos A sine B divided by the cos of A plus B is cos A cos B minus sine A sine B. That's that formula. All right, nice and easy. So now you may ask, so what are you going to do now, sir? What are you going to do? Yes, sir, what are you going to do? Well, what I'm going to do now is I'm going to divide through by cos A cos B. And you might say, why? And notice I have a 1 right here, so I need this part to be a 1. So I'm going to divide through by cos A cos B. Why is this equal not moving? Come with me, not equal. Not getting the equal to move, so let me put another equal here. Yeah, man. So I'm going to divide through by cos A cos B. I'm going to divide each term. So now I'm going to divide both the numerator and the denominator by cos A cos B. So I'm dividing the numerator, the denominator by cos A cos B. I know it looks like a minus, but it is a divide. So now, when I do the division, sine A cos B over cos A cos B, sine A, let me write it out, we will see it better. We're going to get sine A cos B. That part is divided by cos A cos B. Then we have a minus then we have a plus. This part now, which is cos A sine B, this part is divided by cos A cos B all over so in the numerator, that's the division for the numerator. Now we're going to look at the division for the denominator. The division for the denominator will be cos A cos B over cos A cos B. Nice. And then of course we have a minus a sine A sine B over a cos A cos B. When you do that division now, what are we going to get? Let's work it out now. As we can clearly see right here, cos B cancels a cos B, cos A cancels a cos A, Cos AB cancels cos AB. And now what you get is sine A over cos A is tan A. So that's how you get tan A right there. Plus sine B over cos B is tan B. So that's how you get a tan B right there. Then this is all being divided by, this part cancel each other to just get 1. Then you get minus sine A over cos A is tan A, and sine B over cos B is tan B. So that's how you get tan A, tan B. Nice and easy, soft. Nice. That takes care of this. Part 2. Part 2 says, given that sine A is 3 over 5, where A is acute and angle B is obtuse, find an expression for tan A plus B. I would just go ahead and work it out, but because them say obtuse, they throw me off. So I have to put a little diagram right here. And I'm going to just put a triangle in the second quadrant. You have the angle B, and they say cos B is minus 1 over 2, so it is minus 1 because it's in the second quadrant. The hypotenuse is 2, and so we need to find this length. This length will be 2 square minus 2 square minus minus 1 square rooted, and so this is the square root of 3. All right, that is for this triangle. That's for the triangle with B. All right. All right. Now the one in the first quadrant, no need to check. Let us tell us that we have a triangle. Hypotenuse is 5, opposite is 3, so adjacent is 4, angle is A. So we have a 2 triangle them now. And express tan A plus tan B in this form. Now first thing is we're going to write down the formula. Tan A plus tan B. We just proved it a while ago that it's tan A plus tan B over 1 minus tan A tan B. So tan A plus tan B is equal to tan A plus tan B, tan A plus tan B over 1 minus tan A tan B over 1 minus tan A tan B. Nice and easy, soft. So now 1 minus that, so let's go ahead. Tan A now, looking in this triangle, tan A is going to be opposite over adjacent. So tan A is 3 over 4 plus tan B. Tan B is opposite, root 3 over adjacent. So it's plus minus root 3 over 1 minus tan A tan B. So it's over 1 minus tan A times tan B is root 1 minus root 3 over 4. And they want it in this form. Oh gosh, we're going to have to rationalize. So they're giving us a module 1 concept in module 2. So we're going to have to rationalize. So 1 minus this, first and foremost, I'm just going to write it as, I'm going to join it as 1. Instead of saying 1 minus that, I'm going to say 4 minus 3 root 3 over 4. All right. And I'm going to simplify the numerator. I can simplify the numerator as 3 minus 4 root 3 over 4. I'm going to simplify the numerator as 3 minus 4 root 3 over 4. Simplifying it, joining it as one fraction. All over 4. Now, how does this simplify now? If we have a fraction divided by a fraction, just writing it down, if I have a fraction a over b, and it's being divided by a fraction c over d, it's really multiplied. Instead of dividing by c over d, it's multiplied by d over c. So it's going to be this times this over this was 4. So all of this is going to be simplified to be a times d. So it's going to be 4 times this. 4 times 3 is 12 minus 4 times 4 is 16. It's 4 minus 16 root 3 over this times this, which is 16 minus 12 root 3. So now I'm going to have to rationalize. Now I'm going to have to rationalize and multiply by the conjugate of the denominator. But before I do that, I think I can simplify this. I can factor out 4. I can factor out 4. Because this is a big number, I can factor out 4. And instead of writing 12, factor out 4 to get 3 minus 4 root 3. Factor out the 4. Put the 4 right here. And the same thing in the denominator, I can factor out 4. Don't want to be working with such big numbers. I'm going to factor out 4 out here as well. I'm going to have 4 minus 3 root 3. These 4s apparently cancel. So all I need to do is multiply by 4 plus 3 root 3. So I'm going to multiply both the numerator and the denominator by 4 plus 3 root 3 divided by 4 plus 3 root 3. So when I multiply them across, what I'm going to be getting is 3 times 4, that's 12. This times this is 3, that's 9 root 3. Then this will be minus 16 root 3. So 9 root 3 minus 16 root 3 is minus 7 root 3. And then I have minus 4 times minus 3 is minus 12. And root 3 times root 3 is 3. That's minus 36. Divided by, this is now the difference of 2 squared, which is 3 root 3 times 3 root 3. That's 27. And 4 squared is 16. So 16 minus 27 is minus 11. So in the denominator I have negative 11. So now to express it in the form that they want, it's going to be 12 minus 36. 12 minus 36 is negative 24 over negative 11 minus 7 root 3 over negative 11. And since minus and a minus, I can just put plus. So it's plus 7 root 3 over 11. That's how we get this question. Nice and easy, soft. Next part. It says solve this equation. Solve this equation, sine squared theta minus 2 cos squared theta plus 3 cos theta plus 5 equals 0. To solve this equation, we have to change sine squared to 1 minus cos squared. So sine squared theta is really 1 minus cos squared. So change sine squared to 1 minus cos squared theta plus, so we have 1 minus cos squared theta minus 2 cos squared theta. So 1 minus cos squared minus 2 cos squared really becomes 1 minus 3 cos squared theta plus 3 cos theta plus 5 equals 0. Good. All right, that's what we have. So now we're going to bring everything to the other side. 1 plus 5 is 6. Bringing it over, we're going to get 3 cos squared theta. I know you see minus sign there, but I'm going to bring everything over to the other side to get 3 cos squared theta minus 3 cos theta, because I divide through by -1, or bring it to the other side any way you want to look at it. And then 1 plus 5 is 6, so it's going to become minus 6. All I did was divide through by -1 equals 0. So let me put what I did to get the positive 3. I divided through by -1. Now after I divide through by -1, I'm going to do another division. I'm going to divide through by 3. So now I'm going to divide through by 3 to get cos squared theta. And divide through by 3, I get cos squared theta minus cos theta minus 2 is equal to 0. All right. Now, can this be factorized? Can it be factorized? I'm just going to go straight to quadratic formula. When it looks a little different, well, it can be factorized. Let's just factorize it. It can be factorized. Let me see now. Signs are different. The greater product negative, so it has to be 2 and 1. Minus is associated here, and plus is associated here. This must be cos theta, and this part is cos theta. Nice. And so now, really and truly, this part won't have any solution, and so therefore, we only need to look at the part that is going to give us that cos theta is minus 1. Because this part won't be giving us any solution. We don't need to check that. That part has no solution, because cos theta can't equal 2. So cos theta being equal to -1, we draw our circle, and we want where cos is negative. Cos is positive, CAST. Cos is positive here and here, so we want the solution in the second and third quadrant. So first we find out the principal acute angle, which is cos inverse of 1. Cos inverse of 1. When you find cos inverse of 1, that will give you the principal acute angle. Cos inverse of 1 is 0. And so the angle over here is pi minus 0, which is pi. And the angle here is pi plus 0, which is also pi. All right, the cos of pi is minus 1, yes. But look at this, it says it wants theta to be between 0 and 4 pi. So we can go around the circle 4 times. So what we're going to get then is theta can be equal to pi. Going around the circle one more time, we can also get theta is 2 pi. That makes sense. Theta can be 2 pi. 2 pi? No, 2 pi would be associated here. Pi plus 2 pi is 3 pi. My apologies. Pi plus 2 pi is 3 pi. 2 pi plus pi, yes, that's 3 pi. So theta can be pi or theta can be 3 pi. All right, that's by going around the circle one more time. So for those who don't understand how we get the 3 pi, we went around the circle one more time. So that gives us 3 pi. That's how we got the 3 pi. So pi and 3 pi are the solutions. Nice. Good. All right, next part of the question, it says f of theta is equal to 6 cos theta plus 8 sin theta. Express it in the R-sine form. So first we need to find out what is R. R is equal to a squared, which is 6 squared, plus 8 squared, square rooted, 6 squared plus 8 squared, square rooted. And then we square root that, we're getting 10. That's going to be R. Then alpha is tan inverse B over A. So alpha is equal to tan inverse 8 over 6. Alpha is equal to tan inverse 8 over 6. Alpha is tan inverse 8 over 6. So 8 divided by 6. We find tan inverse of that at 0.927. 0.927. That's alpha. 0.927. All right, now that we have that for alpha, now we can express f of theta in that form. So it's going to now be f of theta is now equal to 10 sine, it's equal to 10 sine theta plus alpha. So it's 10 sine theta plus 0.927. Nice and easy, soft. Now that we finish this question, moving right along, part 2. Part 2 says, hence or otherwise, find the general solution of f of theta equal to. Hence mean you set this equation equal to 2. So we're going to set 10 times the sine of theta plus 0.927 come on, give me the dot, 0.927. We're going to set this equal to 2. So setting this equal to 2, first thing we do is divide through by 10. Dividing through by 10, we're going to get the sine of theta plus 0.927 is equal to 2 over 10. And 2 over 10 is really 1 over 5 because I divided through by 10. So now, what you're going to do is, remember, one general solution. All right, so first thing you do is find sine inverse of this. So you're getting that theta plus 0.927, it's equal to sine inverse of 1 over 5. And so what would be the general solution? So you're gonna get that. So if you wanted to write a general solution for theta, let's do it now. General solution. General solution. So the general solution, as you know, there's going to be two values. So the general solution is going to be theta is equal to sine inverse of this minus this. So general solution is theta is sine inverse of 1 over 5 plus 0.927 plus 2n pi. I can go around the circle again, so plus 2n pi. That's one possible answer. Another possible answer is going to be pi minus all of this. Wait, when you bring it over, it becomes minus. So this shouldn't be plus, this should be minus. Sine inverse 1 over 5 minus. Then another possible answer will be pi minus sine inverse of this. So it's pi minus sine inverse of 1 over 5 minus 0.927. You need to put a bracket to show that you work out the pi minus this first, plus 2n pi. That's the general solution. Many persons may want to write like an actual number. So I don't know, depending on how you feel, maybe you like to write actual numbers. So you can go ahead and say sine inverse 1 over 5 minus 0.927, and you get negative something. So you have theta is negative. So maybe you feel good by writing down here. I don't know, it does depend on you. Some persons might prefer better to write minus 0.725 plus 2n pi, and some persons might feel better to write or pi minus that now, which is pi minus sine inverse 1 over 5 minus 0.927. Some persons might feel better in writing 2.013 plus 2n pi, depending on how you prefer write your answer. All right, so those are also possible solutions for theta. It's the same thing. This and this is the same thing. All I did was put the numbers there. All right, so any way you prefer to write it, you're fine. I prefer leave it this way, exact. Okay, moving right along. We reach question 4. Question 4 says, the circle with equation x squared plus y squared minus 4x plus 2y minus 2 equals 0, and C2 have a common center. Given that C2 passes through minus 1 minus 2, express C2 in the form this. So the circle C1 has this equation and C2 have a common center. Oh, that was the information. They have the same center. Okay, that's a nice question. Since they have the same center, we can find the center of C1. The center of C1 is going to be, that looks like 2. The center of C1. So C1 center. So C1, the center is really divide the minus 4x by negative 2. and you get 2, 1. So that's the center of the circle. And then C2 passes through -1, -2. So you have a circle. This is C2. You have 2, 1 is right here. This is 2, 1. Sorry. 2, 1 is the center of C2. I don't know why I put the point on the edge. You have this point right here. Let me label it on the outside, which is 2, 1. And then you have -1, -2. -1, -2 could be, maybe it could be here. That's -1, -2. So if we find the length of this line, it will be the radius. So the length of this line will be the radius. And so the radius R is going to be equal to x1 minus x2 squared. So it's 2 minus -1, which is 3 squared, plus 1 minus 2, which is -1, which is really just 1 squared, square rooted. And so the radius is equal to 9 plus 1 is 10, so the square root of 10. So what does that mean? That means that the equation for C2, that means that C2 is given by x minus 2 square plus y minus 1 square, and it's equal to r square, but the root of 10 square is just 10. It's equal to 10. So this is the answer. Nice and easy, soft. This is the answer. We don't even need so much space. That's the answer for this one. Easy. They're giving away 3 marks. So now it says the equation L1 is x plus 3y equal 3. Determine whether L1 is a tangent to the circle C1. So to determine if L1 is a tangent to C1, I'm going to sketch C1 for us. So C1 is a circle that has center 2, 1. And if L1 is a tangent to it, if L1 is a tangent to C1, that means that, why I keep jumping, that means it only touches the circle at 1 point. So maybe it touches it somewhere there at 1 point. All right, so this would be L1. You would have to touch the curve at 1 point. So there should only be 1 point of intersection. So the equation of C1 is x squared plus y squared minus 4x plus 2y minus 2 equals 0. Let's write that down. We're going to solve them simultaneously, and we should only get 1 point of intersection. So the curve had equation, let's write it down. It was x squared plus y squared minus 4x minus 2y minus 2 equals 0. Let's check that again. Yep, so that was it. All right. Now, looking right here, if I were to make x the subject, from the first equation, x is really 3 minus 3y. So I'm going to substitute x as 3 minus 3y into the curve. Substituting 3 minus 3y into the curve, I will get 3 minus 3y, 3 minus 3y all squared. This up here typed wrong. I want to fix this. That should be 3 minus 3y. 3 minus 3y all squared. plus y squared plus y squared minus 4 times x, where x is 3 minus 3y minus 2y minus 2 equals 0. Now let's see. Let's go ahead and solve this equation to see if we get only one point of intersection. Now going ahead and solving this, it's first term square, which is 9, minus twice the product of the two. 3 times 3 is 9, 9 times 2 is 18, so that's minus 18y. Plus second term square is 9y squared, plus y squared again. Then we have minus 4 times 3 is negative 12. Then we have minus 4 times minus 3y, minus and minus give us plus. So we get plus 4 times 3 is 12. We get 12y minus 2y minus 2, and this is equal to 0. Nice and easy, soft. So since that's what we're getting now, all we need to do now is add up our like terms. 9y squared and y squared is 10y squared, and then we have minus 18y plus 12y is minus 6y, minus 6y minus 2y is minus 8y. And then we have 9 minus 12 is negative 3. Negative 3 minus 2 is negative 5. So we have 10y squared minus 8y minus 5 equal to 0. No. Whoa, this can't factorize, can it? Can I factorize it easy? When I can't factorize it easy, I'll just go to quadratic formula. So y is equal to minus 8, which is 8, plus or minus the square root of b squared, which is 8 squared, minus 4 times a, which is minus 4, times 10, times minus 5, over 2 times a, over 2 times 10, which is 20. So I'm getting that y is equal to, when I work out that square root, you're going to get that 8 squared minus 4 times 10 times minus 5, that's 264, and the square root of 264, I don't even need to work it out, I can stop. So I'm getting 8 plus or minus the square root of 264 over 20. So what does this mean? This means I'm getting 2 points of intersection. So I can stop right here and say, since the discriminant which is equal to 264, which is greater than 0, we are getting 2 points of intersection, and so the line is not a tangent line. It's not a tangent, it is actually a secant line. It's a secant line. It's just a regular line that passed through the circle. That's all. So maybe the line looks something like this. If I were to click on the line just looks something like this. Right, it just passed through 2 points. Just a secant line. Nice. Moving right along. Vectors. It says now Express the vector PQ in the form xi plus yj plus zk. So first thing, vector PQ is equal to vector of the last minus vector of the first. So some C-sec maths here, some C-sec adma. So it's OQ minus OP, OQ minus OP, OQ minus OP, that's going to be equal to vector OQ is 1 minus 2, 4. That's vector OQ minus vector OP. Vector OP is 3, 1, 2. We do the subtraction. What we're going to get is 1 minus 3 is minus 2. So get minus 2i. Minus 2 minus 1 is minus 3j. 4 minus 2 is plus 2k. That's vector PQ. Nice and easy, soft. Nice. That's vector PQ. Now it says determine the Cartesian equation of the plane which passes through the point Q and is perpendicular to PQ. So the equation of a plane is given by R dot n, and R dot n is equal to A dot n, where R is just x, y, z, n is a normal to the plane, A is a point on the plane. When you have a plane and it says PQ, the line PQ is perpendicular to the plane. So this is the line PQ. So if PQ is perpendicular to the plane, and PQ acts as a normal to the plane, and so the equation of the plane is going to be R dot n, n is minus 2, minus 3, 2, that's R dot n, and that's equal to A dot n. A dot n is, A is the point Q, and Q is 1 minus 2, 4. So you have 1 minus 2, 4, dot n, and n is again minus 2, minus 3, 2. And so working this out, we're going to get R dot n works out to be, this is now minus 2x minus 3y plus 2z. That's equal to 1 times minus 2 is minus 2, plus minus 2 times minus 3, plus 4 times 2. And so what we finally get is minus 2x minus 3y plus 2z. And that's equal to, we work that out, minus 2 plus minus 2 times minus 3 plus 4 times 2, that's 12. Nice and easy, soft. That takes care of this question. So this is the equation of the plane. All right, that is the Cartesian equation of the plane is minus 2x minus 3y plus 2z equal to 12. Nice and easy. So now, next line, it says the vector equations of lines L1 and L2 are given by L1 is minus 1 plus j minus 2k plus alpha times minus 2 plus j minus 3k, And then they give us the vector equation for L2. Show that L1 and L2 intersect. If L1 and L2 intersect, then L1 equal L2. So what they're telling us then, since they intersect, L1 is equal to L2. If L1 is equal to L2 at some point, then that means their components are equal. So that means that -1. So if you group up the I terms, you have -1 plus -2 alpha. So that's -1 -2 alpha. That's for L1. Then right here, we're going to have grouping up the J terms. We have J plus alpha, which is 1 plus alpha. And then grouping the K components in L1, we have -2 -3 alpha. And that's grouping the K components for L1. Going to have a look at L2. L2 is -2 plus beta -2 plus beta. Then we're going to have 1 minus beta. And then the third equation, which is the K component, we're going to have -4 plus beta. -4 plus beta. Nice and easy, soft. Now, after we do this now, all we need to do is equate the I components for both lines, the J components for both lines, and the K components for both lines, and it should work out. So let's compare I components. So comparing I components, we're getting that -1 -2 alpha. I'm going to call alpha A in this case. And that's equal to -2 plus beta. I'm going to call beta B. So if I were to bring over this 2 over here, really and truly I'm getting add 2 to both sides. I'm getting -1 plus 2 is 1. So I'm getting 1 minus 2 alpha is equal to beta. That's comparing the I components. Now let's compare the J components. So looking at the J components, comparing the J components, I can see that 1 plus alpha is equal to 1 minus beta. But then what we said was beta. We said beta was 1 minus 2 alpha. So that means 1 plus alpha is equal to 1 minus beta, which is 1 minus 2 alpha, because that is beta. So solving them, we're getting 1 plus alpha is equal to 1 minus 1 gone, minus and minus give you plus, so you get 2 alpha. So bringing over alpha here, we're getting that alpha equals 1. If alpha is equal to 1, going back to over here, if alpha is equal to 1, going back to over here, then that means that 1 minus 2 times 1 is equal to beta, and so beta is equal to 1 minus 2 times minus 1 is 1 minus 2, that's -1. So alpha is 1 and beta is -1. All you need to do is check it in the K component. So check in K component. So we're going to check to see if it is true in the K component. In the K component, we're getting -2 minus 3 times alpha, and alpha is 1. We need to check to see if that is equal to the other side, which is -4, plus beta, which is plus beta, which is -1. So checking the first one, going up here, we see that -2 minus 3 times 1 is -5. And then we see minus 4 plus minus 1 is negative 5. And so yes, the two lines intersect. The two lines intersect. And they do so when alpha is equal to 1 and beta is equal to negative 1. Good. So we get them there. We're nice. Next part. It says, hence, determine the coordinates of the point of intersection. So at the point of intersection, alpha and beta equal 1 and minus 1 respectively. So using L2, using line 2, where beta equal, what was beta, minus 1? So I'm going to use L2. So L2, which is minus 2 minus beta, 1 minus beta, and around here is minus 4 plus beta. So this we can use to find L2. So we just need to plug in beta as minus 1 now. So we can get that. Plug in minus 1, minus 2, minus 1. That's negative 1. Plug in minus 1 here. 1 minus 1 is, I think that's 2. 1 minus 1, that's 2. And then minus 4 plus minus 1 is negative 5. So the point of intersection is minus 1, 2, 5. So point of intersection is minus 1, 2, minus 5. That's the point of intersection. Now we can check it around here. You can also check it when alpha is 1, you get, when alpha is 1, you have minus 1, minus 2 times 1. Oh, I wrote it wrong right here. This is minus 2 plus beta. Minus 2 plus beta. So we need to change this to minus 3. Minus 3. So let's change this here to minus 3. So it's minus 3, 2, minus 5. Yeah, that's the point of intersection. Moving right along, we finally